Good afternoon, Professor. This is my personal timetable. What I've done this week, I'm going to elaborate through my presentation. Uh, in this previous week, I have did research group meeting, which is every Monday, and we have two classes on Friday of Nagendra sir, and next third task is was my radiometer for medical sensing application using different reference noise source. And I have also researched many paper, and I have also reviewed paper uh, for my research work. And current week I will attend my research group meeting on Monday, and next on Friday we have both class, biomedical and physics, and I have to make homework for big data and MMIC coursework assignment, and uh, the fourth task will be on my research work for radiometer medical sensing application. I have gone through many paper, and when the final paper I most find suitable for my research work was this designing and implementation of novel interferometric microwave radiometer for human body temperature measurement. This paper was published just 2 months before on February, and it is the advanced version of previous paper which I have done in previous week. And this in this paper uh, uh, clearly they have nicely mentioned the hardware and software part, and step by step subdivision and subsection also is there in this paper. So I like this paper because it's quite clearly mentioned, and it is latest. It has been published this year 2021. So I like to present this paper. I want to review this paper. So in this paper, what I have studied is that when I studied the abstract part, in that I found that it is a detection device for human body temperature, which is accurate, rapid, and non-contact. The hardware is like architecture of informetric. This thermometer uses 2 gigahertz bandwidth, and it has a phase shifter, which is a correct is used to correct phase error, and contractive demodulator used to realize autocorrection, correlation, and detection function. So the result shows that input power is 7 dBm, and reduction sensitive reaches to 176.54 volt meter volt, and the temperature resolution reaches to 0.4 K. In this design is used, uh, they had used a correction algorithm to improve the accuracy of the temperature measurement. After the correction, phase reduces the temperature 40 degree to 1.4 degree Celsius, and then the temperature changes from 0.1 degree Celsius. The voltage value also changes. In this, mean square error of water temperature has inverse by multiple regression algorithm has been used, like 0.607, and in this they had a BP neural network algorithm, which has a frequency of 0.334. In the introduction part, what I have studied is they had used a infrared technology for detection of human body temperature. As I said, it is non-contact. You cannot touch, and it is rapid also. It If a person is wearing a cloth, then also it can measure a body temperature, and it can monitor the surface of the temperature and subsequent tissues of ICU patient from a distance, with some sort of distance. And in this paper they had mentioned that in COVID-19 it make a positive contribution uh, for prevention. It also helps in maintaining social distancing. This technology helps for maintaining social distancing also. In this what the advantage and disadvantage I find that, first advantage, it is non-contact measurement. Without touching a person you can measure the body temperature, and there is a wide range measurement can be done, uh, and high temperature measurement speed, and it is high sensitive. Disadvantage, penetration detection is not there. Long distance detection, if person is from 10 kilometer away, at that point detection is not there. High precious detection, it has a disadvantage. In this usage of infrared detection technology, currently this thermometer, which is infrared, is widely used in large stations like shopping mall, university, or gathering place. Is infrared technology is used most for. It is a rough temperature scanning system. And the next is the valuation of radiometer. In this, what happened in 2017, what happened in 2015, and what happened in 2009 to 12, I will elaborate by using diagram, and what I have researched with the previous paper. I have gone through the reference paper also, and I found this figure also. In 2017, as this was my first paper, when means not first paper, previous paper, which I was reviewing at that time. I think so, Park and Jeong. In this in 2017, let me come from down to upward. In 2009 to 12, it has a block diagram. As you can see, in 2009 from 12, the improved measurement of antenna in design and antenna is good conductivity, which can radiate energy in analytic direction. It has a hot and cold calibration, isolated, and it is divided in front end section, which has RF and AM, and the down conversion is high pass filter, and it has a mixture, and then it has a reflection section. In that, it has a certain sort of LNA block, DC block, low pass filter, and if AM. And so in previous 2009, they had divided this block diagram for TPR in three section: front end, down conversion, and reflection. And in reflection there was further subdivision, that was low frequency circuitry. Then the output comes. So this is like very a long process. uh, which they had experimented, and then they come with the second version that was 2000 in around 2015. Lee and Lang of Yuzhong University of Science and Technology, they had conducted the study temperature measurement of heart elevation area, cardio radio frequency elevation surgery with C-band Dick microwave radiometer. They carried out the contact in this contact and non-contact temperature measurement experiment of water has been done. In the last, which is held on 2017, Park and John, the radiometer thermometer shows a good performance in water temperature, which measurement is 298.15 to 316 2.25. When you convert this Kelvin into Celsius, it goes to minus. This frequency lies into minus. So this was the major drawback they had in that experiment. And in this you can see the block diagram, which is total power radiometer with two reference load, cold and hot source, and the antenna. Then they are using sp3t switch, and then it is connected to LNA and BPF. Then it has a detector, and then it's connected with a DAQPC and AOB, and after that with a personal computer. By this process, hel- making this process shorter, uh, they had this kind of experiment. So this was the this in this part. This was a slide about evolution of radiometer. Next, in this paper of design of novel heteroferrometric microwave radiometer for human body temperature measurement, they had nicely divided their design flow of thermometer radiometer with two sections. One section is of hardware design, and second section is of software design. As you can see in this flow chart also, first it start with the high directive temperature measurement antenna, which is in hardware. First I will tell the hardware section a subtopic name, and then in hardware second subtopic is interferometric analog complex correlator, and then the third is RF front end circuitry design of radiometer. In the software part, then after the completion of hardware, it comes with the software part. In that it has three major sub topic. uh, First was correction algorithm, and then comes the how the mechanism has been done with hot and cold part, and then the inverse algorithm comes. What I have studied, I will explain through my presentation up till now what I have gone through. In first part of the software design of informametric microwave thermometer radiometer, in that the first part is microwave radiometer offset error. It has a correction algorithm. It's about how to correct the if phrases are wrong, how this algorithm has been used. Means algorithm, it's like a programming language. In this when the microwave radiometer is connected to a sine signal with the frequency 5 gigahertz and power is 0, the second step is like main controller controls the phase shifter to shift the phase by 90-degree step. Then it 2048 group of I and Q channels, I upon Q channels voltage value are calculated at each phase point. Then finally result are stored in a specified path. According to this, the equation becomes for I voltage 10 into I upon 6535 minus 5. It is the equation. And then when you want to calculate voltage Q, that is 10 into Q 65535 minus 5. When you calculate this pi value is calculated by sigma 2048. I starts from 1 arctan iq I upon voltage I whole this equation upon 2048. This was the equation. And now to calculate this sample data of voltage and phase, uh, it is the phase error is like difference between the theoretical phase and the value, and the theoretical phase between the IQ channel. As I said and before also, it has a step in second step it changes the degree to 90 degree. Um in this this is the sample, some sample data of voltage and phase value which starts from 38. And by this way, by using previous equation, you can calculate this. And the phase error of the system is obtained by using this averaging mean value of this phase error and of the sample data. Then the phase shift value of phase shifter is controlled by the system phase error. After that phase completion, the relation between the voltage and the sampled value, the phase value means, should be linear to the intercept in the offset error. And the slope is the parameter. What's the this slope becomes is a gain error, e gain, the idle offset error, e offset, idle and idle, slope s idle r, becomes after for correction, we had changed the um, uh, calculation way. For when idle offset equal to 0, slope idle equation when is calculated by using code max minus code mean, positive volt reference minus a negative volt reference. For the correction equation of offset error uh, and the gain error, uh, offset correction equals to negative error offset, and gain correction equals to S idle upon S actual. S actual is the actual slope. Code correction, code receives and code idle upon actual slopes, and the plus offset corrections. In this, code correction is the corrected sample value and code receive is the received sample value. After this, the experiment, the intercept and slope parameter are obtained using this above equations. Sorry. Okay. Using above equations, you can find the slope parameter and obtained by the linear fitting method, and the gain error and offset error are corrected according to error correction method. This was the error correction method, and the result shows in the figure 9. This is the graph of corrected result of I channel using that max and mean equations. And uh, and then comes the and next figure is about the corrected by this using same correction method. We have calculated the q band also using the correction algorithm. And then the this uh, uh, this voltage and phase error table uses max and mean correction correction algorithm. This table has been made. After the correction, the temperature changes 0.1 degrees Celsius, and average value of voltage changes obviously. In other words, the correction algorithm can reduce the influence of phase error and offset error, and then and gain error of the output result, and improve the temperature measurement. In next slide, this slide is about the flow chart of the correction algorithm. This in this how to start the uh, calibration part of hot and cold. The software part starts from data collection. First it is first you start, then the data is collected. After data collection, data processing has been done. After data processing, you get a phase error. If you get a phase error, yes, then you go to phase shifter. If you don't get a phase error, if phase error is no, this is it phase error has a data type boolean value. It only throws a boolean value. Boolean value has only two parameters, whether it may be true or false. When the error becomes true, it goes to a phase shifter, then it goes to a gain error offset. Uh, if phase error is false, becomes false, it's directly go to the gain error offset. When it goes to gain error offset error, then when gain error offset error has throws the value of true and false. Like if gain error is true, it will have a linear fitting algorithm. uh, as I said in before, when you use code max and code mean equation, uh, then the linear fitting algorithm has been used in that case. And when gain error and offset error is has a true value, it shows a true, we have to use linear fitting algorithm. It has no error, then it has a corrected voltage. So by this way, I have studied that how the software has designed, and this was the flow chart has been made, and how the algorithm and how the programming has been done in this paper. So I have studied this much part up till now. Thank you for the day, and thank you for the presentation.